Okay, let's unpack this. Today we're diving into, well, maybe a surprising intersection: calculus and food security.
Yeah, it's not the first thing most people connect, I imagine. Calculus and keeping food safe.
Right. But our source material points right at it. There's a really interesting link there.
And it's fascinating how these, pretty abstract math tools give us real insights into biological stuff affecting our dinner table.
Exactly. So this deep dive is all about that, how differentiation specifically gets used to understand something critical: the relationship between temperature, enzyme activity.
And how that all plugs into food security. Yeah.
We're looking at how relevant this math concept is in, well, a really fundamental part of life.
The sources specifically flag differentiation in food security, don't they? And highlight the temperature effect on enzymes as a key application.
Okay, so let's break that down a bit. Why enzymes and temperature? Why is that combo so vital for food? And where does the differentiation part fit in?
Good question. So enzymes are basically like the workhorses in food. They drive reactions.
Like ripening, fermenting.
Exactly, the good stuff sometimes. But also the bad stuff, spoilage. Enzymes breaking down proteins, fats, makes food go off, Texture changes, bad smells.
And temperature controls how fast they work. We all know that stick it in the fridge.
Right, but it's more nuanced than just colder or slower. That's where calculus comes in.
Oh, okay.
The rate at which enzyme activity changes with temperature, it's often not simple, not linear. It can subtly speed up a lot with just a small temperature rise.
Right, it's not a steady climb.
Precisely.
Yeah.
And differentiation is the tool, the math, that lets us measure that rate of change exactly. How much faster does that spoilage enzyme work for each single degree hotter it gets in that critical danger zone?
Okay, so it's not just knowing, say, 10 degrees is worse than 5 degrees. It's knowing how much faster the spoilage kicks in between 5 and 6 degrees compared to between maybe 0 and 1 degree.
That's it, exactly. You got it. That speed of the change, that's the derivative. That's what differentiation tells us.
And knowing that rate is key for food security.
Absolutely crucial. If you know how quickly a spoilage enzyme ramps up with heat, you can make much smarter decisions about handling food.
What kind of decisions? Can you give an example?
Sure. Imagine researchers analyze a key spoilage enzyme in, say, fresh berries. Using differentiation, they might find its activity barely doubles going from 0 to 5 Celsius,
Okay.
but it quadruples going from 5 to 10 Celsius.
Wow. Okay, that's a huge jump for just those few degrees.
It is. And knowing that precise rate of change, that acceleration, that's the power of differentiation here. It informs everything.
Right.
Optimal storage temps, predicting shelf life during bumpy truck rides.
Designing heating processes to kill off bad enzymes without wrecking the food itself.
Exactly. It turns general knowledge, heat spoils food, into precise, actionable data for controlling how fast things degrade.
So the research really frames this as calculus providing, like the hard numbers needed to improve the whole cold chain, cut down waste, and ultimately help make sure food is safe and available.
That's the core idea. Applying differentiation to enzyme kinetics gives us the quantitative handle we need to manage those risks. The risk of spoilage, essentially. It directly impacts food safety and availability.
So wrapping this up, it really means these complex math tools, like differentiation, they aren't just stuck in textbooks.
Not at all. They're out here helping analyze fundamental processes, biological, chemical, things vital for something as basic as having enough safe food.
And understanding the rate of change is often the key to controlling the process itself, which leads to, well, a question for you listening.
Yeah.
Where else? Where else in the everyday world might this kind of sophisticated math be working behind the scenes, providing critical insights we just, haven't even noticed?